Today, we're going to trace the incredible story of mathematics, from the very first marks on a bone all the way to the invisible codes that run our entire modern world. And believe it or not, it all starts with a simple question. It sounds like a strange riddle, right? But the answer is really the core of our story. It connects the literal dawn of human thought to the fabric of our digital lives. You see, that ancient wolf bone, it's one of the first pieces of evidence we have that humans were counting. And your bank account? Well, its security depends entirely on a branch of math that, for centuries, was seen as this beautiful but totally useless puzzle.
So how in the world did we get from there to here? This timeline gives you a kind of bird's-eye view. We started simple, just by counting things. Then the ancient Greeks gave us geometry to measure the world. Later on, algebra gave us a brand new language for abstract problems. Calculus let us finally understand a world in constant motion. And all of it, every single step, has culminated in the digital age we're living in right now.
Okay, so let's start at the beginning. Our story doesn't begin with abstract numbers, but with a very real, very physical problem, just trying to understand the world around us. For our ancestors, math wasn't a school subject. It was a tool for survival, for building, and for navigating this massive, unknown planet they were on.
Now, think about that question. I mean, it feels impossibly huge, even for us today. But Aristophanes, this brilliant scholar at the legendary Library of Alexandria, he believed he could answer it without ever leaving his corner of the world. All he figured he needed were a few simple observations, one piece of information, and the pure power of geometry.
The logic here is it's beautiful. So Aristophanes knew that on a certain day in a city called Syene, the sun was directly overhead, no shadows. But in his city, Alexandria, at that exact same moment, a stick did cast a shadow. That angle, 7.2 degrees, that was the key. He realized the only reason for that difference was the curve of the Earth. So he thought, if 7.2 degrees is just 1/50th of a full circle, then the entire planet must be 50 times the distance between those two cities. It's just a perfect piece of logical deduction.
And the result? It's absolutely mind-blowing. His calculation, 39,250 kilometers, is less than 2% off from what our modern satellites tell us. I mean, let that sink in. He measured the entire planet using a stick, a shadow, and his brain. That is the raw power of math in the physical world. So, measuring the physical world was a huge leap. But the next revolution? It was all abstract. Mathematicians started to create a new language, not for things they could see and touch, but for the things they couldn't see, the unknown.
And this is where algebra enters the picture. The word itself comes from the work of the amazing 9th century Persian scholar Al-Khwarizmi. His system of algebra was all about restoring balance, about finding a missing piece to put broken parts back together. He was creating a systematic way to solve for x, for the unknown, and that idea was going to change everything.
You know, before algebra got its modern symbolic language, solving a problem like this was a real mouthful. In the 16th century, a mathematician like Cardano had to write equations out in longhand, a mix of Latin words and abbreviations. Now, compare that to our clean, super efficient version today. This wasn't just a style change, it was a revolution in thinking. These symbols let us juggle really complex ideas with incredible speed and clarity.
But this jump into the abstract, it wasn't always easy. For centuries, concepts that we just take for granted were seen as complete nonsense. The 12th century Indian mathematician Bhaskara could solve an equation and get a negative answer, but he had to basically throw it away. I mean, negative numbers didn't correspond to anything real you could hold, so how could they possibly be an answer? It took a really long time for us to accept that math could describe things beyond our immediate physical experience. Okay, so we figured out how to measure a static world and how to solve for a static unknown, but there was one huge problem left. Our world isn't static. It's always moving, it's flowing, it's changing. How could math possibly describe that? Seriously, think about it. To find the speed of a cannonball, you need to know the distance it traveled over some amount of time. But what's its speed at one single frozen instant? In an instant, no time passes and no distance is covered. It was a total paradox, and it stumped the greatest thinkers for centuries. It was a major barrier to really understanding the physics of the universe.
The answer, it turns out, was calculus.
Developed in the 17th century by Isaac Newton and Gottfried Leibniz, this completely revolutionary system gave us a way to work with the infinitely small, those tiny, frozen moments in time and space. And for the very first time, we could precisely analyze and predict a world in motion. It unlocked the laws of physics, astronomy, and engineering. It was a total game changer.
And that brings us to our final part, where the whole story really comes full circle. We're about to see how the most abstract, the most seemingly impractical ideas in math became the unexpected foundation of our modern digital world.
Let me introduce you to number theory. For literally millennia, mathematicians studied the properties of numbers, especially prime numbers, just for the pure intellectual challenge, for the beauty of it. It was famous for being the purest form of thought, with absolutely zero connection to the real world. It was just a game, you know? A beautiful intellectual exercise. And for centuries, that's all it was. Until the world changed, and suddenly we needed a brand new kind of lock for a brand new kind of world.
So here's the genius part. The cryptography that protects almost everything you do online is built on a really cool property of prime numbers. It's super easy for a computer to take two massive prime numbers and multiply them together to get a new number, m. But it is monumentally, almost impossibly difficult to take m and work backward to find those original two primes. This one-way trick, that's the lock.
And just like that, the purest, most useless field of math became one of the most essential technologies of the 21st century. Those idle thoughts of ancient mathematicians are now the invisible shield that protects our entire digital lives. It's just incredible.
What a journey, huh? We went from just carving notches on a bone to measuring the earth with a shadow. We invented a whole language of symbols to wrestle with the unknown. Then we tamed the idea of infinity to finally understand change. And in this beautiful final twist, we found out that the most abstract ideas can have the most profound, real-world impact.
And that leaves us with a really fascinating final thought. The history of math shows us time and time again that the line between just pure curiosity and world-changing technology is never where we think it is. It really makes you wonder, what abstract puzzles are mathematicians working on right now, just for the love of it, that will one day become the bedrock of a future we can't even begin to imagine?